Today we're going to cover polynomial functions. Specifically, we are going to classify polynomials and describe the end behavior of polynomial functions. Some vocabulary. A monomial is a number or a product of numbers and variables with a whole number exponents. Basically, there's one term with no addition or subtraction. Now, the degree of a monomial, you find that by adding the exponents on all the variables. So we have three examples of monomials. Notice, no addition, no subtraction, all three are monomials. Now, if I want the degree of the monomials, I simply add up the exponents. I have a 4 and a 3. So the degree of this monomial will be a 7. The next one, I have the invisible 1 on the E. I have the invisible 1 on the D. So the degree will be 2. Now for the last one, the 3, there are no variables. Because there's no variables, then there is no degree. The degree is 0. Next, polynomials. A polynomial is a monomial or multiple monomials put together with adding or subtraction. It's not a polynomial, and this is the big one, it's not a polynomial if the variable is in the denominator, if it's a root, or if it's in absolute values. So polynomials, we have a monomial here, we have a binomial, we have a fraction here. That's okay because I still have a whole number for an exponent, I have another whole number for an exponent, and I have a binomial there. Now, things that are not polynomials, and these are the keys, the nots. Absolute values are not polynomials. Notice the exponent is in the denominator, then it is not a polynomial. We could take that one step farther and say it would be a negative exponent. I could rewrite this 8/5 v to the power of -2 if you were dealing with negative exponents, still not a polynomial. Here I have a root. And in addition to the roots, you could say, well, that is the same thing as x to the power of 1/2. Remember, your fractional exponents are the same as roots. So any fractional exponent would be not a polynomial. And here again, I have a decimal as an exponent, which can be rewritten as 3/4 for a fractional exponent. So anything with a fractional exponent or a root or an absolute value is not a polynomial. You'll need to know the names of the different polynomials. We already covered one term, that's a monomial. If there's two terms, we call it bicycle has 2 wheels, binomial has 2 terms. A trinomial, just like a tricycle, has 3 wheels. A trinomial has 3 terms. If it has 4 or more terms, we simply call it a poly, meaning many. Now the degrees of the polynomials are easier than the degrees of the monomials. You simply go off the largest exponent. So the first one, it's a degree of 0 because there is no variable. Linear, if you're y equals mx plus b, you have an invisible 1, that's a degree of 1. Quadratic, x squared, you should know how to graph those. Cubic, we graphed those also, has an x cubed there. Quartic, just like a barber shop quartet, has 4 people, then a quartic has an exponent of 4 on the largest, and the quintic has an exponent of 5 on the largest. Now, if we're naming these, we had one term here for a monomial, a binomial, another monomial, a trinomial, a binomial, and this has 4 or more terms, so it's a polynomial. Now what we want to do is a few examples. Classify each polynomial by its degree and the number of terms. The first one has a square on it, and I see 2 terms. The square tells me it's a quadratic, the 2 terms tells me it's a binomial. The next one has an exponent of 4, thus it's going to be quartic. And I see 1, 2, 3 terms, which means it's going to be a trinomial. And the last one here, the largest exponent is a 4, so I'm going to have another quartic, and this time I have 1, 2, 3, 4 terms, so 4 or more will be a polynomial. Standard form. We've dealt with standard form many different times before, and this one's no different. For standard form, you always put it in largest to smallest based off of the exponents. So here the largest was a cubic, constant is always at the end. So standard form starts with the biggest exponent and decreases until you only have the number or the constant term. Coefficients. Coefficients are the numbers in front of the variable. So if we look here, 3 is the coefficient in front of x squared. 4 is the coefficient in front of x. 3 at the end, that's just a constant, that's not a coefficient. So if I ask you what the coefficients are, you tell me 3 and 4. The coefficient we're going to use the most, though, is going to be the leading coefficient. It's the number in front of the variable with the largest exponent. So here our largest exponent is a square, so our leading coefficient will be 5. Now when dealing with these, most of the time what we're going to want to do is put the polynomial in standard form and then take the leading coefficient. Now here's a few examples. They gave us a polynomial 8x plus 3x squared minus 5. The first thing we want to do is put that in standard form. The 3x squared goes first, then the positive 8x and the negative 5 is at the end. Now the leading coefficient is the number in front of the largest variable, and since we put it in standard form, we simply go off the front. The 3 is our leading coefficient, and the degree would be the largest exponent. Here the degree would be a squared or just a number 2. Now take a minute and go through this table and try to finish it real fast. Okay, now check your answers real fast. Our leading coefficient for the second one is 1, and the degree is a 4th degree. Put the x to the 4th first. Our leading coefficient for the second one is that invisible 1, so we have a negative 1 because the x to the 4th was a negative. So our degree again is 4. And the last one, a binomial, our leading coefficient is the invisible 1, and our degree is 2. All right, more vocabulary. Now note, before we get into the vocabulary, when you're graphing, if I'm talking about negative infinity, it means my graph is going to the left. If we're talking about positive infinity, that means my graph is going to the right. So negative infinity to the left, positive infinity to the right. Now, end behavior. End behavior describes what happens to the ends of your graph. It's basically as the x is approaching positive or right and negative to the left of infinity. So as your graph is going to the left and right, what is happening? Now the degree and leading coefficient, things we just talked about, will determine this end behavior. Now here's a nice little table with no pictures. The next table will have pictures in it. If your degree is even, think of an x squared graph. X squared is an even degree, and that means both ends are going in the same direction. So if your a is positive, it's going to go up. If your a is negative, a negative x squared, then we know it points down. So we've already graphed these before, and that should make sense. An odd degree would be something like an x cubed graph. Notice that the ends are going in opposite directions. So a positive x cubed graph, as we go to the right, our graph is going up. As we go to the left, our graph is going down. And then when we have a negative a term, we flip it. Pictures are a lot easier to understand, so here's a few pictures. Odd degree, our x cubed graph, and this basically is an x cubed graph right there. As x goes to positive infinity, that means to the right, what is happening to your graph? It's going up also to positive infinity. As your graph is going to negative infinity, that means the left. So as my graph is going to the left, what is happening to the graph itself? It keeps going down. That's a normal x cubed graph. If we switch it and have a negative x cubed, things simply switch. As I'm going to positive infinity, that means as I'm going to the right, what is happening to the graph? It's going down. As I'm going to negative infinity, that means to the left, what's happening to the graph? It's going up. So notice that your leading coefficient simply flips it upside down. Now over here for our x squared terms, this would be a positive x squared, U-shaped. So as I go to the left, the graph is going up. As I go to the right, the graph is still going up, which means no matter what, my graph is going up. If I have a negative x squared, no matter what, my graph is going down. So as I go from negative infinity or to positive infinity, my graph is still going down in the same direction. Let's go through a few questions. This one says to identify the leading coefficient, the degree, and the end behavior. Now if we take a look at this, it's already in standard form. That makes life really easy. Our leading coefficient is the number in front. So we have a negative 1 right there. Our degree is the largest exponent, which is right there, the 4th degree. So that means that the basic shape is going to be a U shape but because it's a negative in front, then we know our basic shape will be pointing down. Negative leading coefficient points us down, and the even degree makes it U-shaped. Now they want the end behavior. So we can say as x goes to both positive and negative infinity, so both left and right, then our graph q of x also goes to negative infinity. As x goes to positive and negative infinity, then q of x goes to negative infinity, meaning the graph is pointing down. Here's another one. Again, our leading coefficient is the number in front because it's already in standard form. We have a 2. Our degree is the largest exponent, which is right here, and that is 5. Because 5 is an odd number, we know that our graph is going to be basically an x cubed graph. Now it's going to look a little different, but the ends are going to be an x cubed graph. Because the leading coefficient is a positive number, we know it's going to be a normal graph like this. So we can say as x goes to negative infinity. Now that's the left. So what's happening when the graph goes to the left? The graph is also going down. Down would be negative infinity. Then, as the graph goes to the right, then it's also moving up. As it goes to the right, it's moving up to positive infinity. All right, now they're going to give us the graph and ask us if it's a positive or negative leading coefficient, and if it's going to be an odd, even degree. So I look at this graph and I see that it's going in opposite directions. It's going up and it's going down. Well, I can ignore all of the different curves, and those are called turning points. So I have a turning point, a whole bunch of turning points. We'll talk about those in a minute. But right now, we're simply looking at the ends, end behavior. And the ends are behaving in opposite directions. So since they're going in opposite directions, I know that it's an odd degree because they're going in opposite directions. Now, if I know my normal x cubed graph goes up when it's going to the right, but this one is going down. So because this is going down as it's going to the right, then I know it's a negative leading coefficient. Again, negative because it's going down as it goes to the right, and it's odd because they're going in opposite directions. This one is going in the same direction, so we're going up and we're going up. Because they're going in the same direction, then I know it's an even degree, and because it's going up, I know that the leading coefficient is positive. All right, here's a couple more problems. These are multiple choice, so they should be a little bit easier. The first one says f of x equals x minus 6 to the power of 4. Well, if it's an even, right there, I have a power of 4, it's an even, that means I know that it's going to go in the same direction. If the leading coefficient is positive, and it is, it's an invisible one, then I know it's going up. So I know at some point I should have a U-shaped going up. Now, what does the little negative 6 inside tell us to do? It actually tells us to shift our graph 6 to the right. Remember, graphing quadratics, nothing's changed. We're shifting it 6 to the right. So if we go through this, I know that this is odd and it's negative. I know that this one is even and negative because it's pointing down. Also, it hasn't been shifted left or right. The center's right in the middle. This one is odd and it's positive because it's going up on the right. And then this one over here is even and it's positive. And notice it's been shifted to the right also. So obviously that is our correct answer. All right, the next one says negative x to the power of 8 plus x to the power of 4. Well, x to the power of 8 is our largest, so our degree is going to be even, and our leading coefficient is negative. See the negative 1, I know it's small, but we have our leading coefficient of negative 1, and our degree is 8. So we're looking for something that's a U-shaped and pointing down. The very first one, letter A, we know that's odd, but it is negative. Letter B is also odd, but it's positive. Letter C is even because they're pointing up. It's positive. And at the very end, we have a U-shaped pointing down. So that is going to be even and negative, which is what they're asking for. And that is our right answer. We have one more. It's x cubed is our leading number. So we have a leading coefficient of positive 1, and we have the degree of 3. So we're looking for an odd that's pointing up. Letter A is even. Letter B is odd and pointing up. Letter C is also even. And the letter D is odd and pointing down, so that's going to be negative. We needed a leading coefficient of positive and a degree of odd. So that would be letter B. Now, turning points. Turning points are where your graph turns. So if we look at the picture right here, we can see that it's turning where the arrow is there and where the arrow is here. So it looks like a type of x cubed or an odd graph, and it has two turning points. What that's going to give us is a local minimum and maximum. Think about it. A regular x cubed graph is not going to have a minimum or a maximum because it's going to go forever. So our turning points give us a local minimum and maximum. So here you're going to see a maximum that's in the highest point, and then you're going to see a minimum at the lowest point. Now what this does is it gives us an opportunity to write our intervals. Basically, as I read the graph, just like I read a book, from left to right, what is the graph doing? When is it going up and when is it going to go down? Well, we can see that the graph is going up from negative infinity all the way until we reach negative 1. The graph again is going to go up to positive infinity. So we would say our graph is going up from negative infinity until negative 1, and it's going to go up from 2 all the way until positive infinity. So this is when your graph is going up. The graph is going down from the negative 1 all the way until positive 2. Now, if we're going to label our local maximum and minimum, we have a maximum here at negative 1, 8. Remember, the graph is going by 2's in the y direction. So negative 1, 8. And then we have a minimum over here at 2, negative 4. And again, the reason why it's called a local is because the graph goes to infinity, so there would be no max and min except in this small area. So here I have graph f of x is equal to 2x cubed minus 18x plus 1. We're going to have to do it on a calculator. I don't expect you to do it by hand. They want us to estimate the local max and min and then write the intervals. So if we go over to our Desmos, it's actually very convenient because if we click on the graph, they'll show us the local maximum. Our local maximum is right there at negative 1.7, 21.8. And our local minimum is down here at positive 1.7, negative 19.8. So those would be our max and min. Now, if we need to write the intervals, we can simply look at the graph going from left to right. From negative infinity all the way up into our negative 1.7, the graph is going up, and then at positive 1.7 to positive infinity, it's also going up, and in the middle, it's going down. Here's another one, x cubed minus 2x minus 3. Simply go over to Desmos, click on the graph, and it'll tell you your maximum at negative 0.8 and your minimum over here at a positive 0.8. So we had negative 0.8, negative 1.9. And the minimum is down here at negative or positive 0.8, negative 4.08. We'll round it to 4.1. Now for doing the intervals will be the same as the others. From negative infinity all the way up to 0.8 is positive. From negative 0.8 to positive infinity is going to be positive also.